In the last class, we have discussed about AVL tree, how to generate AVL tree. Now, in this class, we will discuss some important terminologies related to tree data structure. So, we have already discussed that what is tree? Tree is a non-linear data structure. Tree is a non-linear data structure. Okay, so if you want to define any particular tree, then you have to define it like this. It is a finite set of vertices, okay, connected by edges, uh, and mm, so these are actually called the vertices. These are vertices, or sometimes called nodes. Okay, and the connection between two vertices is called the edge. So this is edge. These are vertices. This one, suppose this one V1, this one V2, and this is the edge between these two is called, say, edge A12. Okay. Now same terminology is used also in case of graph. Graph is also a kind of non-linear data structure, but the basic difference between graph and tree is, remember this is very important difference. The basic difference between graph and tree is, in case of graph there may be cycle, in case of tree there will be no cycle. Now what does it means? So suppose a structure of three node, so or three node or three vertices, and there are two edges. Now see, this is a picture of a tree, this is a picture of a tree, but if I somehow link this two, then it becomes a cycle. Why it is become a cycle? Because if you see from this particular vertex you can reach to this particular vertex, then you can reach this particular vertex, and then you can get back to this vertex. It means there is one particular edge which is starting from a vertex and also ending to that vertex. So this type of thing is called a cycle. Okay, so now whenever it is having this cycle, this type of thing, then it will be no more called as a tree, it will be called as a graph. Okay, so this is the basic difference between graph and tree. All are finite set of vertices connected by edges. So in case of graph there may be cycle, but in case of tree there will be no cycle. Now so you can say that tree is one kind of graph without cycle. Tree is one kind of graph without, so in case of graph there may be cycles, but in case of tree there will be no cycle. So you can say that tree is one kind of graph without cycle. Okay, in graph we will see there is a spanning tree. In graph there is one concept which is called spanning tree. So it means from graph we have to generate some tree without any cycle. So this is the basic difference. Okay, so this, the connection is called edge.
हेलो सर
হ্যাঁ বলো
हेलो सर
বলো
স্যার আগের দিন আপনি ক্লাসে একটা আমাদের এ এক্স বি ওয়াই দিয়ে একটা সিকোয়েন্স দিয়ে ওটাকে একটা
হ্যাঁ
এভিএল
হ্যাঁ
ট্রিতে সাজাতে বলেছি।
হ্যাঁ
ওটা
হ্যাঁ
ওটা একটু ওটা করেছি সলভ, ওটা আপনি যদি একটু বলে দেন বা তাহলে মিলিয়ে দেখতে পারবো।
আচ্ছা ঠিক আছে, আমি এই ক্লাসটা মানে আমি তো এখন দুটো ক্লাস আছে পর পর, এইটা হয়ে যাক, তারপর আমি ওই ক্লাসটাতে আমি ওটা করে দিচ্ছি, ঠিক আছে?
আচ্ছা ওকে স্যার, ওকে স্যার,
হুম
ওকে
হুম
স্যার।
ওকে। So these are the called vertex or vertices or node. The connection is called the edges. So this is basic definition. Now if this is one kind of tree, and we already discussed that the topmost node is called the root, okay, and the nodes without any children is called the leaf. So here this one and this one, these two are the leaf node, okay, these two are the leaf node. Now there is other some terminologies like this: internal node and external node. So what do you mean by internal node? Internal node, so any node which is having children. If a node having some children or child, it is called internal node. It means the external node means the leaf nodes. The leaf nodes don't have any children. So in this particular picture, this is one internal node I, you can say. This is another internal node I, and these two are leaf node or external node E. Okay, so this is another definition of external node and internal node. Now there is another interesting term used, is called a degree. Degree of a node. Degree of a node. So degree of a node is actually the number of children. The number of children belongs to belongs to that node. That is called the degree. So for this particular node, this root node, what is the degree? Since it having two children, so the degree of this root node is 2. What is the degree of this one? This external node or leaf node? The degree of external node or leaf node is 0. No children is present. For this particular internal node, what is the degree? The degree is 1, because only one children. So this is the meaning of degree. Okay, degree of a node, this is the degree of a node. Similarly, the degree of a tree, degree of a tree is actually the maximum degree, then that is called the degree of a tree. Okay, now there is we have also discussed the levels. So if again we draw a picture of a tree like this. So if this is a picture of a tree, uh, so then you can say this is level 0, this one is level 1, this one is level 2, this one is level 3. Okay, then what is the height, or sometimes called, you can say, depth? You remember, depth or height is maximum level plus 1. So what is the maximum level for this particular tree? For this particular tree, maximum level is 3. So its height is 3 plus 1, that is 4. Okay. Similarly, you can see that a tree is always recursive. It means for this particular node, this root node, there is two different trees. This is called the left subtree. This is called the left subtree. Okay, and this is the right subtree. Okay, similarly for this particular node, this is the left subtree, there is no right subtree. For this particular node, this is the left subtree. For this particular node, this is the right subtree. So in this way you can see that a tree can be partitioned into different subtrees, which is again itself is a tree. Okay, that's why they are called left subtree, right subtree. This side is left subtree, this is right subtree. And we have already seen that for to calculate the balance factor of the AVL tree, to calculate the balance factor of the AVL tree, we have uh, calculated it by height of left subtree minus height of right subtree. So we have already discussed this. Okay, now there is another thing which is called a path. Okay, path means from any particular node to any another node, the path is like this. This is called the path. Okay, there is a branch. If a branch means starting from the root node to the leaf node, that is called the branch. Okay, there is another interesting thing which is called internal path length. Internal path length. Okay. Now, what is the meaning of internal path length? Internal path length means the total path of all the internal nodes. Okay. Now, what do you mean by path? First we have to decide which are the internal node. For this is one internal node. We have already discussed what is internal. This is another internal node. This is another internal node. This is another internal node. So these are the four internal node. Okay. Now the path of each internal node is the height of that particular node. Height, or you can say level, height or level of that particular node. So what is the level of this internal node? 0. Okay. What is the level of this internal node? 1. What is the level of this internal node? 1. What is the level of this internal node? 2. So this is the total internal path length. Okay, 4. Similarly, what are the external path length? If we want to calculate the external path length, these two are the external node. What is the path length of this external node? This is 2. For this level is 3. So the external path length, external sorry the external path length equal to, for this particular example, it is 2 plus 3, that is 5. So this is the different terminologies used in case of any tree. So you have to just remember this definition. There is another, we have discussed another definition, that is what is full binary tree. Full binary tree. Okay. So full binary tree means the picture is like this. Each level having maximum number of nodes. Each level having maximum number of nodes. Okay, so this is a full binary tree. Similarly, there is another definition which is also important for our heap data. Heap, if we want to perform the heap shorting, there is another shorting that we don't cover in our shorting phase. It's called heap shorting. To create a heap shorting, or to create a heap, this remember, this heap is not the heap memory. This is not the heap memory. This is not the heap memory. There, heap is a tree. Heap is a tree. Okay. So heap tree is actually called another kind of binary tree, which is called complete binary tree. So there is two different types of binary trees, you can say. One is full binary tree. So this is the picture of a full binary tree, each and every level having maximum number of nodes. So this is level 0. What is the maximum number of node? 2 to the power 0. For this, 2 to the power 1. For this, 2 to the power. So every level having maximum number of node. This is called full binary tree. Or you can say, you can also define full binary tree like this, that each and every node having 2 children except the leaf node. Each node having 2 children except the leaf node. So this is another definition you can say. Now see, there is another interesting tree which is called complete binary tree, and when we will discuss heap tree, we will see heap tree is one kind of complete binary tree. Heap tree is one kind of complete binary tree. And the exact definition of complete binary tree, you can say that it has all the levels except possibly the last one having maximum number of nodes. In this full binary tree, every level having maximum number of nodes, but in complete binary tree, all levels except the last level having maximum number of nodes. This is one thing. And the last level appear as far left as possible. Okay, now in this full binary tree, all levels, so you can say all levels having maximum number of nodes. This is the full binary tree. In complete binary tree, all levels except the last level having maximum number of nodes, and the last level appear as far left as possible. Now what do you mean by as far left as possible? Now see the picture for complete binary tree. Now see, in case of full binary tree, the number of node is fixed. The number of node is fixed. If it is a only 0 level, then only one node. If it is only having 0 and 1 level, then 3 nodes. If it is having 0 1 2 level, then 7 nodes. So number of nodes for full binary tree is fixed. Now suppose I have to create a tree for 4 nodes, but I want to maintain it like a full binary tree. Then what I will do, I will draw a picture like this. First level 0 maximum number, level 1 maximum number. Now comes the next level. Now in next level I am only giving one node because already I have covered 3 node. So fourth node will be appear as far left as possible. So this is the only possible picture for this 4 node structure. Now see, for 4 node structure we can draw picture like this. We can draw picture say like this. We can draw picture like this. So we can have many different structure for 4 node binary tree, but which one is a complete binary tree? Level appear as far left as possible. So this is the complete binary tree. These are not complete binary tree. So just try to understand what is the picture of a complete binary tree. If we are creating only one node complete binary tree, it will be like this. 2 node complete binary tree, like this, not like this. 3 node complete binary tree, so it becomes full binary tree. This is also full binary tree. This is full binary tree. Then 4 node complete binary tree, it will be like this. Okay. Then 5 node complete binary tree, it will be like this. Then 6 node complete binary tree, it will be like this, as much left as possible. I cannot add this in this side, then it is not a complete binary tree. First I have to fill the left child, then I will go for right child. So this is then the next one with 7 node. This is the 7 node complete binary tree, and again it becomes full binary tree. Then the 8 node, if I want to draw a 8 node binary tree, then it becomes like this, complete binary tree. So first I have to complete the left child first, left child, okay, then go for the right child, and it will be drawn like this, left to right, left to right. You have to create the nodes left to right. This is called complete binary tree. Okay, so see, complete binary tree, in case of complete binary tree you can accommodate any number of nodes, but in case of full binary tree the number of node is fixed. So that's why there is another type of definition of this type of tree which is called complete binary tree. There is another tree which is called extended binary tree or two tree, sometimes called two tree, or extended binary tree, extended binary tree. the uh, the definition of extended binary tree or two tree is uh, each node has either zero children or zero child or two children. This is the definition. It means a picture like this. This is two tree. This is also two tree. Now this is also two tree. Okay. In complete binary tree, we can accommodate single node one after another. But in case of extended binary tree, now see, this is also a extended binary tree. This is also allowed. Why? Because each node has either 0 or 2 children. 0, see here 0, here 2, here 2. So this is two tree or extended binary tree. So just remember this particular types of binary trees. Now we will go to discuss another very important thing about this binary tree, that is called traversal. This is very important. Traversal of a binary tree. Okay. Now see, in this traversal technique means, what is the meaning of traversal? Visiting the nodes, or you can say displaying the nodes. This is the meaning of traversal. Okay. So now suppose I have a binary tree like this. Suppose I'm drawing any random binary tree. Now suppose this is a binary tree. Okay. Now these are the values or data that is stored in the binary tree: a, b, c, d, e, f, g, h, I. Okay. Now traversal, in case of binary tree, there are basically three different traversal. One is called pre-order. Okay. Another is called in order. Okay. And another is called post order. Clear? Now pre-order means the sequence is like this: first visit, then go for left subtree, and then go for right subtree. In case of in order, the sequence is first go for left subtree, then visit, then right subtree. Okay. In post order, the sequence is first go for left subtree, then right subtree, and then go for visit. Okay. So L stands for go to left subtree. Now we already know what is subtree. R stands for go to right subtree. Okay. And V stands for visit or display or print when you will print the value. Okay. When you are traversing, you will print the value, that is the visit. Okay. Now we have only used, see, there are three different variables. We can have different values like this: LRV, LVR, then RLV, RVL, RLV. But we have only taken this three: VLR, LVR. Why? Because this three actually represent, this pre-order actually represent the prefix expression. This in order represent infix expression. This post order represent postfix expression. So we have already covered this expression. So how we will represent them? See, the expression will be represented like this. Suppose I have to represent a plus b. This is one expression. This in infix. So it will be drawn like this, and actually this is done in our compiler. When you will learn the automata and compiler, you will learn how this binary tree, or this tree is actually generated. So this is the plus symbol, this is A, this is B. Okay, now what is the meaning of prefix or pre-order traversal? First visit. So remember, we always start our journey from root. Okay, we always start our journey from root. So I will start from this is the root. I will start from this particular position, from root. What is written in pre-order? VLR. So just write VLR in each and every node. VLR in each and every row. Okay, then what is the first thing that you have to do? Visit. So visit means you will print it. Visit done. Then what is the instruction? Go for left subtree. So I will go to the left subtree. In left subtree, what is written again? VLR. What is the first thing? Visit. So I will visit. Done. Then go for left subtree. There is nothing in left subtree. Then go for right subtree. There is nothing in right subtree. So all done. Then I will get back to this function, this plus. Now left is done. Now what is the instruction? Go for right subtree. So I will move into right subtree. Now in right subtree, what is written? VLR. So first visit. So I will visit. Okay. Then go for left subtree. Nothing. Then go for right subtree. Nothing. So my this part is done. So I will get back. Now my R done. So everything is crossed. It means I have already completed all the instruction. Now what I have got? I've got plus AB. See, this is nothing but the prefix. Okay, now what is in infix? What is in infix? In infix the sequence is LVR. So write LVR on each and every node. প্রত্যেকটা নোডের উপরে আমি LVR লিখে নিলাম. Again we have to start from where? We have to start from root. What is the first instruction? Go for left subtree. So I will move into left subtree, this side I will move. Then in left subtree, what is written? Go for left subtree. There is nothing for this particular node. There is no left subtree. Done. Then visit. So I will print. Okay, then go for right subtree. There is nothing. So I have completed this. Then I will get back to this. So now my left subtree visit is done. Now what is visit? So visit mean plus. Okay, then I will go for right subtree. In right subtree, first instruction is go for left subtree. Nothing. Then visit. So print. Then go for right subtree. Nothing. Done. So I will get back. Now my right subtree is done. So what I have got? I have got the infix expression. Now see, if I want to calculate the post order, then I will write LRV on each and every node. LRV, LRV. Okay, now again I will start from the root. What is written? Go for left subtree. I will move into left subtree. What is written? Go to left subtree. There is nothing. Then go for right subtree. There is nothing. Then visit. So what I will get? I will get A. Done. Then I will get back to this. Now in this, left subtree is done. Now it is asking me to go for right subtree. So I will go to right subtree. In right subtree, what is written? First go to left subtree. There is nothing. Then go to right subtree. Nothing. Then visit. So visit. Okay. Then I will get back to this. Now my right subtree done. Now the next thing is visit. So plus. Now see, this is nothing but the postfix expression. So that's why only this three particular order is used. No other like RVL or RLV is used. Only this three, VLR, LVR, LRV, is used to traversal. Okay, this is very important. Now for this particular node, this particular tree, if I want to calculate any of the sequence, suppose first I will try the Inorder Traversal. So what is I have to do in Inorder Traversal? LVR. So what I will do, I will write LVR on each and every node. LVR, LVR. I will write it like this: LVR, then LVR, then LVR, 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 then LVR. Okay, then I will start my journey from the root. What is the first instruction? Go to left. So I will move into left. What is the first instruction? Go to left. I will move into left. Okay, left. So I will move into left. Here again left. There is nothing. Done. then visit. So first visited node is D, then go for right subtree, there is nothing, so I will get back from there to there. Okay, now what is my left subtree is done. Now what is there? Visit, so I will print visit. Then I will go for right subtree, so I will move into this. Then again, what is the first instruction? Go for left subtree, so I'll move to the left subtree. Now I am in this position. Now what is written here? Again, go to left subtree, there is nothing. Then the visit, so I will visit this. Okay, visit done. Then go for right subtree, there is nothing, so done. Now I will get back to this. So left subtree is completed. Now it is visit. Okay, so visit is done. Then go for right subtree, there is no right subtree, so done. Get back to this node. Okay, the right subtree is done for this node. Now I will get back to this node. Left subtree is done for this particular node A. Now what is written? Visit, so I will visit. Okay, then I will go to right subtree, so I am now in this node. What is written? Left subtree, there is nothing in left subtree, so the next thing is visit, so I will visit. Okay, then go for right subtree, so I will move into this position. Now what is written here? First go to left subtree, so I will move into this position. What is written here? Left subtree, nothing. Then visit, so I will visit it. Okay, then there is no right subtree, done, so I will get back to this. Left subtree of this particular node is done. Now visit, so visit. Then it will go for right subtree, so I will now in this particular node. What is written? First go to left subtree, there is nothing. Then visit, so I will visit. Then go for the right subtree, there is nothing, so done. I will get back to this particular node, right subtree is done. Then I will get back to this particular node, right subtree is done. Then I will get back to this particular node, right subtree is done. Okay, so this is the in order sequence, in order traversal of this particular node. Now this is a little bit time consuming method, so I will show you one easy method. আমি ক্লাস নিচ্ছি, ক্লাসে পরে ফোন করছি। Okay, so this is a very simple method. I hope it is now I will show you another easy method to understand. So the method is like this. Suppose this is a particular node. Okay, and you are traversing the node like this. Okay, when you are traversing or visiting the node from this left side, if you consider this is the left side, and if you print the node name when you are visiting the node from left side, then you will get pre-order. When you are visiting the node from the bottom, if you print at that time, you will get in order. When you are visiting the node from the right hand side, in this side, then you will get a post order. So this is another interesting thing which you can easily decide what is the in order, pre-order, post order without calculating so much thing. Okay, now see, so again I am drawing the same particular tree in this position. So just okay, so again I am drawing the tree. So the tree is like this. This is A, this is B, C, D, E, G, this side F, H, I. Okay, now you have to draw a picture like this. This is I called amoeba like picture. So you are traversing from this side, you are going like this, and then you are traversing like this. Okay, you are traversing like this, you are traversing like this, and now your traversal is completed. So one amoeba like picture. So which order you required? Suppose you required pre-order, so from which side you have to visit the node? From the left side of the node. So I'm start moving from this side. So first I visit from left side is A, so I'll write A. Then comes B. Okay, then D. When I'm in this position, D. See, I'm visiting them from left side. Now again, so there, from visiting from left side, E, then visiting from left side, G, then again moving, visiting from left side, C, visiting from left side, F, visiting from left side, H, sorry, H, then visiting from left side, I. So this is the pre-order traversal. This is the pre-order traversal. Now I need in-order traversal. So in-order means when I will visit it from the bottom, then I will print. So I'm moving. I'm moving. See, I'm visiting it from the bottom. So first I will visit D. Then I'm moving. Now I'm visiting B from the bottom. Then I'm moving. I'm visiting G from the bottom. Then I'm moving. Now I'm visiting E from the bottom. I'm moving. Now I'm visiting A from the bottom. Now I'm moving. Now I'm visiting C from the bottom. Since there is no left child, so I'm visiting C from the bottom. Then I'm moving. Now I'm visiting H from the bottom. Now I'm moving. I'm visiting F from the bottom. Now I'm visiting I from the bottom. Then my journey is complete. Okay. So this will give me in order. Similarly, if I want to calculate the post order, then I will have to print it when I'm visiting them from the right hand side. So I'm moving. So first I will visit D from the right hand side. So D will come first. Then moving. G, see, right hand side, G. Then moving. E, right hand side. Then moving. B, right hand side. Then moving. H from the right hand side. Then moving. I from the right hand side. Then moving. F from the right hand side. Then moving. C from the right hand side.